Okay, so question number 5. What is the best Lewis structure for, I believe this is called the bromate ion, but basically BrO4 minus. And what is the formal charge of the bromine in the structure? So first, let's count out the total number of valence electrons. Bromine contains 7 valence electrons, and oxygen contains 6, and there are 4 oxygen atoms, so we multiply this by 4. And finally, since the overall ion has a -1 charge, we're going to add an additional electron to our count. And this gives us a total of 32 valence electrons. Yeah. So now let's draw bromine as our central atom. And then I'm just going to form single bonds to each of my oxygen atoms. So notice that none of the oxygens have a full octet yet. Let's see what happens if I drew in all of the lone pairs on oxygen. Okay, so right now, everything looks like it has a full octet. But if we were to calculate the formal charge of each of these atoms, then you'll notice that each of the single bonded oxygens will have a -1 charge. So we're going to form double bonds for 3 of them only. And bromine is one of those elements that can have more than 8 electrons in its valence shell. And we're left with the following structure. So now let's also double check to see how many electrons are in this structure. So if we count them all out, each bond contains 2 bonding electrons. And we have 1, 2, 3, 4, 5, 6, 7 bonds. That's 14. And we have 32 electrons in total. So from here, let's calculate the formal charge of each of the ions, or each of the atoms. So the equation for formal charge is the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. Okay, so first we're going to calculate the formal charge of bromine. So this was asked in the question, so let's just find out what its formal charge is. So bromine has 7 valence electrons, and this bromine contains 0 lone pairs, so there are no non-bonding electrons. And lastly, there are the 7 bonds to the bromine, so we have 14 valence electrons. And if we divide that by 2, we get 7 minus 7, which is just 0. So the bromine is neutral. And now let's do the formal charge of the 3 double bonded oxygens. So the double bonded oxygens, they'll have 6 valence electrons. Each of them have 4 non-bonding electrons. And they all have the double bond. So there are 4 bonding electrons in total, divided by 2. So all of the double bonded oxygens would be neutral. And finally, let's calculate the formal charge of the single bonded oxygen. There are 6 valence electrons. The number of non-bonding electrons for the single bonded oxygen is 6. And lastly, since there's just a single bond, there are 2 bonding electrons that we divide by 2. So 6 minus 1 is -1. So we know that the single bonded oxygen contains the -1 formal charge. So now let's see what the junior tutor said. They have the same structure, and they have the equation for formal charge, number of valence minus, so they count the number of bonds attached to it. So that's another method of calculating the formal charge. Instead of doing bonding electrons divided by 2, you can simply just count the number of bonds. So it's the same thing, minus the number of non-bonding electrons. And they got a formal charge of 0 for the bromine, and this solution is correct.